So we get something that looks more organized. So now we can clearly see the confirmed cases. We can see the total count. We can see the total amount split by males, split by females, split by the percentages, and then the crude rate. And then we can take something that like that and make it even more advanced and more easy to look at. So we can start visualizing the data. So here, I'll give a bad example first. Let's say we want to look at coronavirus cases in the U.S. And I gave you a graph like this. Why is this a bad example? Does anyone want to shout out?
You know, it only really tells you one thing, and that's the number of cases, and it's not even really legible or clear that that's what it
Yeah,
is.
exactly. So if I were interested in knowing the amount of coronavirus cases in the U.S., this is a pretty bad example. Just because it doesn't really tell us anything about the U.S. Yeah, it's not comparable to others to other countries. Even within the U.S. itself, it's giving us one blanket number, as you mentioned, and that's not really helpful to us. And if we were interested in looking at what we can do to prevent more cases from happening, so here we have a good example or a better example. I don't want to say good. You can always improve it. But yeah, so if we're looking at the coronavirus case in the U.S., let's say we give something like this. So now we have a lot more information. We know specific areas that are being affected. We know the hotspots. We know the kind of the distribution of how cases are spread out. We can see that the East Coast is pretty heavily affected kind of uniformly, whereas the West Coast, there's certain hotspots where there's a lot of cases. So this is just a better example of presenting the data. And we have another example here. So just going back to the table, I mentioned that we can see that the rate of coronavirus cases for women and men are a little bit different. But even for the average viewer, if you're just looking at it in a table, it's not always intuitive for you to automatically assume that this little box or cell of the data means this and this cell means something else. And so when we're publishing or presenting the data to someone else, we can take all that information and present something that's easily digestible like this. We can see that for every 10 deaths among women or 10 deaths among confirmed cases of women, there's 13 in men. You can see that the difference is clearly 3 boxes and that there's 10 and 13 boxes. So yeah, that's just a pretty good representation of the data. And then overall, again, why is this important? What can we do with this data? So now that we've presented it, or we organized it, we summarized it, we presented it, what do we want to do? We can start predicting. And so this is particularly relevant with coronavirus, just because, with something like this, we want to predict what's going to happen in the future and predict what can we do to circumvent more cases from happening. So here we have a graph of California, a graph of Florida, showing the confirmed cases. And we can see, it's hard to see a little bit, but that today line is the current, this was taken a little bit back ago, but back in March, but that is today, that little dotted line. And we can see what's estimated to happen in the future. So using that data, we can say, it's going to be likely that there's going to be X amount of cases in the future. And we can start doing stuff about it. So if we know that, for example, California might be affected less in the future, our protocols for changing public policy and things like that might be slightly different than something like Florida, where there's expected to be more cases. Yeah, and so of course, this is really important because all this data tells a story, and we can do something about this. And so, without further ado, I'll pass the baton to Natalia and Ashwin, who will explain the activity that we'll be doing today, just so you guys can get a better idea of how to do this in practice.
Okay, awesome. Thank you, Jeffrey. Okay, yeah, so for our first section of the activity, we're going to be using our beads, and then we're going to organize them by color. Jeffrey, next slide. Yes, so we will basically put everything that Jeffrey said into practice with our beads. So we're going to organize our data, our beads through color, and then we will count the number of beads in each pile. And then we're just going to add that into a shared Google spreadsheet that our volunteers will share with you when we are in our breakout rooms. Awesome. Okay, so now we are going to do that. So I will open the breakout rooms and I will send you guys all in there. Numbers into like one singular picture, and we're able to easily compare it with each other and analyze the relationships between the categories or the numbers or variables at hand. So can you guys give me examples of some types of graphs that you may be seeing? Feel free to drop them in chat. Let's see. Yeah, bar graphs. Yeah, that's honestly like the OG graph. Maybe what's that graph that's like in a circle? Point graphs. Okay, okay. How about like the graph that's like in a circle? Yeah, pie chart, exactly. I think it's kind of like divided up. Ooh, line graphs are interesting too. Yeah, awesome. Thanks for sharing, guys. Yeah, so these are kind of like the types of graphs that you can make out of data. So you have your line graphs, you have your pie charts where you're able to see the composition of something, and you have bar graphs. So as you guys can see, each graph, they kind of have its own type of purpose. So in terms of bar graphs, if you want to compare values, it's the perfect graph for that because through the heights of each like variable, you're able to compare them with each other. If you want to show the composition of something, a stacked bar graph or a pie graph is the way to go. If you want to understand the distribution of data, like how spread out or how close together your data is, scatter plots and histograms are great. If you guys are interested in analyzing trends, particularly over time, then line graphs are perfect. And finally, if you want to understand the relationship between value sets, you should use a bubble chart because through the size, the color, and the location of the bubble, you're able to kind of analyze and compare the differences between the data. Awesome. And then so what we do with these visualizations is that we're able to put them into dashboards where you're kind of, and what a dashboard is where you analyze this one particular data set and then you make different kinds of visualizations based on that singular data set. So as you can see in this example, we have graphs of, we have data all about the street trees in New York City, and then we're able to create graphs out of that, as you can see in this dashboard. And then this dashboard, we kind of have data all about social media. You can see how many likes someone got, how many subscribers. And as you can see in these dashboards, you're able to see different kinds of graphs and you're able to get a general overview of the data set that you're working with. And then finally, a graph that I'm sure all of you probably looked at some point of the pandemic. We have the COVID-19 dashboard by Johns Hopkins University. So if you guys look over here, I'll show you this dashboard. Yeah, so as you can see, we have this dashboard and then it shows data all about the pandemic. And then you're kind of able to see the number of deaths in each country, how many cases there are in the world. And then we have this beautiful map graph that is very interactive and you can like zoom into certain places and you're able to pinpoint how many, say, cases were in a certain place. Yeah, so awesome. Okay, perfect. Okay, so now enough about talking about graphs. Let's actually make graphs. So we'll be using Google Sheets to make graphs out of our bead set. So how we're going to make a graph is first you're going to highlight the cells you need, and then you're going to click Insert, then you're going to click on Chart. And then through these options over here, you're able to customize your graph. So you can select what kind of graph you want to make, you can select the colors. And then I will show you an example right over here of how we can do that. Okay, awesome. So here, I will highlight the cells that I need, and then I'm going to click Insert. Then we're going to create a chart. And then my chart is over here. And then at the side over here, you can select the types of graphs that you want to create out of your data. Yeah, so feel free to just play around with it, customize it. And then notice here, so looking at this graph over here, what do you guys find wrong or misleading about this graph? And I'll give you a hint, it's about the colors of the graph and the beads at hand. Feel free to drop your thoughts in chat. So what is wrong with this graph? Exactly, thank you. Yeah, so the color of the beads does not match the color it's specified in the graph. And in terms of this can be very misleading. So you just want to make sure that the graphs you're making is very, it's very clear about what you're working with. And yeah, because we don't want any confusion to be, we don't want any confusing things to arise from when we're making these visualizations. So you want it to be an accurate reflection of the data that is based on, the data that's being based on the visualization. Awesome. Okay, so now we will go back into our breakout rooms. And then we will first create a graph out of your own bead set. Then after that, you guys are going to work together to create a graph based on everyone's bead sets combined. So you're going to collaborate to customize this graph and try to be creative. And then we want to make sure that the group with the best graph, will win additional points. So you guys can have a chance to win some awesome prizes. Okay, so we will go back into our breakout rooms, and then I will reopen all the rooms.
Yes, so everyone, thanks for making the graphs. Now we're going to be talking about analyzing and forming conclusions. In data science, this is pretty important because once you have your data, you really want to leverage it to, make value. So some questions we can look at right now are what did we learn from the data? So, which color was the most frequent, which color was the least frequent? In terms of different data science tasks, we would ask questions like these after, gathering our data like we just did. And another question to think about is, do you think other groups will have the same answers as you? Why or why not? Okay, so now your task is to make a prediction. So each group member has 30 beads, and I think there are 4 groups now, not 6. So we're gonna ask you guys to predict how many red beads you expect in total out of all the groups. And the group with the closest prediction will win additional points, which they could use in that raffle. Yeah, next slide. Cool, so yeah, we're gonna go into breakout rooms. See you guys there.